Welcome back to Radio Signals. My name is Mark, and my call sign is N9WIB. This is the Technician License Series, lecture number 7, and today we will complete the Electronic Components 2 lecture. During this presentation, we're going to review semiconductors, diodes, transistors, integrated circuits, review some protective components such as fuses and circuit breakers, and finally end with explanation and representation of different switches and relays. In previous presentations, we learned what a good conductor and a good insulator are. Semiconductors lie someplace in between. They're not perfect conductors, nor are they perfect insulators. They lie someplace in between a good conductor and a good insulator. The element silicone is a good example of a semiconductor. Silicone can be what's called doped to create either an N-type or a P-type semiconductor. Doping is essentially the addition of other elements to change the ability to conduct electricity. So doping will either make it a better conductor, or addition of other elements will make it a better insulator in varying degrees. In an N-type semiconductor, there's an abundance of electrons, so this is known as negative or N-type. In a P-type, there are a lack of electrons or the presence of holes, and this is represented by a P-type. A diode is a semiconductor that allows current to flow in one direction only. It's essentially a one-way valve. So just think of it as allowing water to flow in one direction, but does not allow water to flow in the other direction. But in this case, it's electricity. The anode of a diode is referred to as the positive end, and this is with respect to the conventional flow of current. So in the anode, conventional current enters the anode. In the cathode, conventional current exits the cathode, and it is known as negative. If you look at the actual component or the schematic diagram, you're going to see a line on one side of the component, and that line represents the cathode portion of the component. Sometimes diodes are actually put together to form something called a rectifier, and heavy-duty diodes can form a rectifier to actually smooth alternating voltage into DC current. Other types of diodes include the LED, or light-emitting diode. These use much less power and are much smaller than regular incandescent bulbs. And these are some pictures of diodes. On the far left, the multicolored bulbs are known as light-emitting diodes. On the far right is a typical regular diode component in a electronic circuit, and you can tell that there's a little bit of a gray portion or a gray stripe on the cathode portion of the diode towards the top. There are also schematic symbols for the diode. On the far left, this is your regular electronic component with the anode at the base of the triangle being a positive end, and on the negative end of the component or schematic, you'll see that line that we mentioned before. This is the cathode or negative end. And the LED is simply a regular diode diagram with two. Transistors are another type of semiconductor. These semiconductors are made up of NPN or PNP type layers. And this is specifically for a bipolar junction transistor. You're not going to have to know the specific type for your tech exam, but this is something you will likely have to know if you move on to general or extra class. So the important things to remember with transistors for your tech exam is that transistors can act as electronic switches, or they can act as amplifiers. And amplifiers can increase something called gain. So you have increased gain, that means a signal, be it RF signal or something else, has increased gain or amplification. Integrated circuits are essentially single small chips that are composed of multiple different transistors and other components. So you can have as few as a few transistors on a integrated circuit to thousands, if not millions of small transistors and components on a single chip. And this is obviously makes miniaturization of computers and everything else much, much easier. In this slide, we can see the different types of transistors. So on the far left upper portion, you'll see the schematic diagram for a type of transistor called the field effect transistor, or FET, or FET. Now, the FET has different electrodes to it. It has the gate, drain, and source. That you will not need to know for your tech exam, but will need to know down the line. Just know that the field effect transistor, or FET, exists. And there's a photograph of one of them, or a few of them, at the bottom left-hand portion of the screen. On the far right is going to be your most common type of transistor, called the bipolar junction transistor, or BJT. There's the PNP or the NPN. And the schematic diagrams are represented in the slide. And in the center bottom is the integrated circuit. So, as I mentioned before, the integrated circuit has a whole bunch of different components to it, a whole bunch of different transistors, all packed into one single device, one single chip that facilitates miniaturization. But again, for the technician portion of it, just remember that there are different types of transistors, and that an integrated circuit is something that is made up of different types of electronic components and transistors. Circuit protection is very important. It's essentially a device used to interrupt or open a circuit if a current exceeds a certain threshold. So if there's too much current flowing through a circuit, this will interrupt the flow of electricity. Circuit breakers are an example, fuses are an example, and they're there to protect circuits from overload. They're there to protect circuits from from getting damaged by an excess of current, and they're also there to protect you and protect against fire. Fuses are an example of circuit protection. Fuses are one-time use, so if the fuse is used or blows, that's it. You need to replace it with another fuse. Essentially, a fuse is composed of a segment of metal, and if a certain value of current is exceeded, that metal will melt, creating an open circuit or a break in the circuit where electricity and current cannot flow through that. Fuses are rated in amps. So let's say a fuse is rated at a value of 1 amp. If you put more than 1 amp through the circuit, that circuit will blow. So if you put 2-3 amps through that circuit, that fuse will melt, and you'll have to find out what the problem is and replace the fuse after you fix the problem. There are also different types of fuses. There's the slow blow or the fast blow. The fast blow, if you exceed the current within a circuit by any degree, that fuse will blow or activate. Slow blow allows for devices like motors or things that have a very initial high peak in current draw, such as motors or something else, to allow that current to go back down to a smaller level and continue to run. So if a motor is initially activated, it'll draw a significant amount of current for maybe a few seconds, and then it'll go down to a much lower basal level of current usage. So you don't want that fuse to blow immediately, because that's what the motor needs to do to start up. So you want to utilize a slow blowing fuse for that and not a fast blowing fuse. Otherwise, you'll have to replace the fuse every single time you start the motor. Another important thing to remember is that if a circuit breaker or fuse blows and you need to replace it, find out what the problem is. That circuit breaker or fuse activated for whatever reason, because there was a short circuit or an excess of current draw within the circuit, and you need to find a problem before you replace it with another fuse. And never, ever, ever replace a fuse with a higher value. So if the fuse is rated for 10 amps and it blows, don't put a 20 amp fuse in the circuit. You're just bypassing the problem and asking for trouble. Circuit breakers are a device that can be used more than once. So circuit breakers are essentially tripped. They're electronic switches. If a current is exceeded, then that switch will activate and create an open circuit if that threshold of current is exceeded, meaning it's going to form a break in the circuit. So there's no more flow of electricity if a 10 amp circuit breaker experiences a load of 15 amps. That circuit breaker will trip and not allow the passage of electricity. Again, they can be reused and reset after the problem is fixed. So don't just reset a circuit breaker, find out what tripped it. Gfcis, or ground fault circuit interrupters, are also a method of circuit protection. This essentially detects a mismatch or imbalance between current going into the device and current going out of the device. If there's any discrepancy or any change in current flow between the input and output, that GFCI is going to trip. These are commonly found in kitchens, bathrooms, and they're for your protection. So the current mismatch indicates a potential shock hazard, and that's why they are activated to protect you from an electric shock. In this slide, you can see various types of circuit protection devices. On the top, you would see automotive fuses that look like little rectangles with feet on them, and more cylindrical devices. That is another type of fuse that's commonly used. On the bottom left, that black rectangular device is a circuit breaker, and you can see the 15 on there. And so that 15 is for a current value of 15 amps. So if the current is exceeded, if the circuit starts drawing 16, 17 amps, that circuit breaker will trip. And on the far right is the ground fault circuit interrupter. This is commonly, again, found in bathrooms and kitchens, and will detect any discrepancy of incoming current from outgoing current. And if there is a significant discrepancy, it'll activate and shut the circuit down. Switches are used in a circuit to disconnect and connect a path of electricity through a circuit. So a switch is open if it does not allow current to pass. A switch is closed if it creates a path for electricity to flow. A relay is a switch controlled electronically by an electromagnet. A normal switch is manually operated, meaning you have to physically press a button or turn a dial or move a lever back and forth. But a relay is controlled electronically by an electromagnet. So let's review some schematic diagrams of switches. The single pole, single throw is going to be the most simplest switch you can get. So the electricity comes in here and goes out here only if the switch is closed. And this is known again as the SPST, or single pole, single throw. Down here, you have a double pole, single throw, or a DPST. So you have two poles and a single throw, meaning that these two actuate at the same time. On the right side, you have a single pole double throw switch, or an SPDT switch. And you can have electricity come in here, and it can actually go to you can activate two separate circuits, one at a time. And finally, this is the double pole, double throw, or DPDT. So we have two input sources here, and up to 1, 2, 3, 4 output sources. And let's complete the presentation with a review of some miscellaneous schematic diagrams. So for this, on the far left, let's review the battery. So this is a single cell battery, and which is represented by a negative terminal on the smaller side and a positive terminal on the larger side. On the one below it, as you can tell, is a multi-cell battery. It's a multi-cell because it contains essentially two of these components over here. So you have one cell and another cell, meaning this is composed of two cells, or a multi-cell battery. In the center, we have various types of ground. The one to the far left is an earth ground, meaning this is hooked up to earth. The next type of ground is the chassis ground, and this is hooked up to your chassis on your device, your metal chassis. And finally, this thing that looks like a spade is called common ground, and this will go back to the ground on your power supply. And of course, something that we're going to be using all our amateur radio careers is the symbol for the antenna on the far right, which looks like a little bit of a pitchfork. So that about sums it up. We've now completed electronic components lecture number 2, and we learned a lot about semiconductors, specifically diodes, transistors, and integrated circuits. We also reviewed circuit protection with fuses and circuit breakers, and also ground fault circuit interrupters, and introduced you guys to different types of switches and schematic diagrams for various electronic components. So that's it. Have fun, 73, and don't forget to like us on YouTube and subscribe to the channel. And if you want to consider supporting our channel, please go to radiosignals.org and click on the Support Us link. Thanks.